Hello! In this talk from the 2024 JSON Schema Conference, we will discuss what it takes to apply software engineering practices to schemas. In other words, we will be discussing what I like to call the JSON Schema first approach to API specifications. So, why should you listen to me? I am a member of the JSON Schema Technical Steering Committee. I recently published an O'Reilly book touching on JSON Schema. I did award-winning research covering JSON Schema at the University of Oxford, and maintain a growing amount of tooling and resources in the JSON Schema ecosystem like learnjsonschema.com, which you might have heard of, and I also have my own company, Source Meta, offering products and services around JSON Schema. If you work with APIs, you definitely know what API specifications like OpenAPI and AsyncAPI are, and the benefits that they provide, such as serving a single source of truth for what the API offers, and enabling interesting use cases like generating documentation, generating stubs and SDKs, enabling automated contract testing, and also helping new users find you through API registries like apis.io. API specifications are getting extremely popular nowadays. The chart that you see at the right is from the Postman State of the API report, where they survey a large amount of people in the API space. According to that report, over 90% of respondents use or know JSON Schema. You can also see pretty high numbers on OpenAPI too. So this is clearly important stuff. And if you're watching this talk, chances are that you are already using at least some of these API specifications and built on top of JSON Schema. Let's say that you're starting to use OpenAPI. It all starts great, and you begin by describing some initial parts of your API. And in just like 68 lines of YAML, you get pretty cool interactive HTML documentation of your first endpoint. To take it from there, you start adding a few more endpoints to describe an entire CRUD resource. And you still get a really cool result in just like 249 lines of YAML, which is not bad. But most APIs, they consist of more than a single CRUD resource, right? And turns out documenting more real-world APIs takes quite a bit of effort. Now at this point, we have a complete Hello World API specification in just like 800 lines of YAML. The thing is, it doesn't end there. Real-world APIs are much more complex than the Hello World API we just defined. And before you know, you're starting at an OpenAPI specification consisting of like 140,000 lines of YAML, like this one from Stripe. That's what a production-grade API really takes, and it's not nice at all. This huge OpenAPI document will choke various tools I tried, like Postman and RapidAPI. And of course, it's not that Stripe is doing a bad job. They offer a fantastic API, and they had to come up with lots of internal tooling to still be able to follow a specification-first approach. So there has to be something we can do to manage this increasing complexity of writing OpenAPI specifications for real-world APIs. And here is the key observation. If you look at that huge Stripe OpenAPI specification, which you saw, more than 80% of it is JSON Schema. That makes you think for a bit, right? The key point here is that virtually all API specifications out there are in a way just wrappers around JSON Schema. JSON Schema is a core foundational technology enabling all of them. Which gets us to the realization that if you want to improve your API specifications, you should actually focus on improving your JSON schemas. And this talk is going to be an introduction to exactly that. So, how do we improve JSON schemas? I'm currently making a living helping organizations succeed with JSON Schema, involving a lot of consulting and hands-on help. And the most common pitfalls that I've seen so far are: first, defining entire ontologies of schemas within the API specification. In other words, some people end up defining collections of hundreds of schemas all in line within the same monolithic YAML OpenAPI file, making it really hard to even reason about and follow what's going on. And often as a consequence of the above, some people end up copy-pasting schemas in various API specifications because there is not a single place to reference them from. Then eventually the API specifications diverge, and hell breaks loose. Lots of confusion. This is a big one. More often than not, I see that schemas are not being unit tested at all. Many times they seem reasonable, but actually they don't validate what they're supposed to validate, or they permit more than they should, and nobody ever realizes that for a long time. Also related to the above, when looking at big collections of schemas, I often see schemas that are plain invalid, they use wrong keywords and more. And again, nobody realizes for a long time, if any. Now this is more of a subtle one. I often see schemas that, even though they work, they are overly complex for what they're trying to validate. They are full of bad practices, anti-patterns, and more. And last but not least, I often see organizations inadvertently adopting JSON schema implementations that are actually not fully compliant. Then it all seems to work well within the same system, but issues occur when distributing schemas at large or when communicating with systems written in other programming languages that use a different JSON schema implementation. Again, lots of confusion and time wasted. So that takes us to what I like to call the JSON schema first approach to API specifications. And it might sound fancy, but it's actually really simple. It just means that you should treat your schemas with the same care that you treat your code. If you remember anything from this talk, this is the key. Again, you should treat your schemas with the same care that you treat your code. And the good news is that you already know how to do all of it. So let's get practical about it. Assuming that you're a software engineer, surely you don't write all of your projects in a single huge monolithic code file, right? However, that's exactly what I see plenty of API developers doing with their API specifications. Lots of YAML, all in a single file that is extremely hard to grok. Which takes us to the first step. Before you can properly do anything else, first, extract your schemas as individual files on a GitHub repository. Otherwise, if you don't do that, it's very hard to do more advanced things to improve your schemas within the constraints of like an OpenAPI wrapper. Just way more difficult than it should. Plus, now you get the added benefit that you can use those schemas in other API specifications without copy-pasting them by referencing them from a single place. Because you actually now have a single source of truth. In fact, the idea of extracting and maintaining your schemas in an independent repository, it is so important that Kin Lane, very famous for its API evangelist website, heavily promotes these ideas as, and I'm quoting, the fundamental of getting your schema house in order. Luckily, it's not hard to find great examples of organizations and companies doing this very well. For example, take a look at how AsyncAPI itself does it, as well as the KrakenD API gateway, and even NASA. And finally, nowadays there is even tooling to automatically extract schemas from an API specification, often referred to as unbundling. So there are no excuses. It's a really important and high return of investment step that is extremely easy to do in like 5 minutes. So go for it. Moving on, another very important step is making sure that whatever tool you use to work with JSON schema is actually fully compliant. This is another very simple step that can save you from lots of headaches later on. And as a shameless plug, I do write and maintain my own JSON schema CLI, which I'm going to be showcasing for the rest of the talk, but it's definitely not the only one. You're more than welcome to use any other one. But I still think that you would enjoy my CLI a lot. It has been designed specifically to solve a lot of the real-world use cases that I keep hitting and getting involved in. If you're a macOS user, you can install it from Homebrew using the command I'm showcasing here. If you visit the project website on GitHub under the source Meta organization, you can find precompiled binaries for other platforms and instructions to use it in Docker, GitHub Actions, and NPM as well. But other than that, I want to talk about AJV for a minute. If you're doing anything in the JavaScript ecosystem with JSON schema, you probably know AJV. It's a hugely popular JSON schema validator. However, most people don't realize that it's non-compliant. And in fact, it is the least non-compliant popular implementation that we're aware of. If you check Bowtie, that's the official JSON schema project to publicly rank compliance of implementations, you will see that AJV results in hundreds of errors with the official JSON schema test suite across dialects of JSON schema. Now, AJV can be especially configured to fix some of those through various opt-in options, but a lot of other ones are completely unfixable. And if you're using AJV, things might seem fine as long as you use AJV everywhere, but if you are publishing your schemas to the world or interacting with other schemas, I guarantee you will encounter some weird problems sooner or later. either because AJV will refuse to process valid schemas that you want to use, or because using AJV as the main tool will push you to write non-compliant schemas. So, as a very simple advice, just avoid AJV. Always check bow-tie first to make sure that you select compliant implementations no matter what programming language you're using. Then you're going to be safe. The next step is also pretty simple. For every single schema you write, make sure that you validate it against this meta-schema. This is analogous to checking if your code actually compiles. For the schemas, it will tell you if your schema is not valid at all from the point of view of JSON schema. And you would be surprised by how many cases I found of people not doing this. But let me give you an example. Take a look at this schema. Looks good, right? Actually, this is not a valid schema. The items keyword in its array form was renamed to prefix items in JSON Schema 2012. And unless you know a lot about JSON Schema and the differences between versions, and maybe even then, I guarantee you will miss things like this, mainly when they are part of bigger schemas. I would definitely miss them too, and I did. My JSON Schema CLI provides a Meta-schema command that can easily protect you against all of these things. You can see how I'm running it for the schema above and the useful error message that I'm getting back. And just to repeat this once more, sounds obvious, but you would be really surprised by how many people end up accidentally writing schemas that are not valid with respect to the meta-schemas. Moving on, when writing code at work, you might be relying on tools that automatically format the code for you. These often come with IDEs or as standalone tools like Prettier, Rust format, Go format, you name it. However, many people use code formatters, but I see very few people use formatters for schemas. It is one of those things that we take for granted in code, but somehow we completely forget about them when working with schemas. And schema formatters are great for improving readability and ensuring that all of your schemas follow a common style. See the example schema that I have here, which is purposely very messy. My JSON Schema CLI supports a format command, and if I run it on the above schema, I get this pretty result. Not only indentation is fixed, as you can see, but the keywords were reordered to also improve readability. First, we show the dialect, so we know how to read the rest of the schema. Then we provide a schema-wide metadata at the top, like schema identifiers, titles, and all that. Then we include type information, if any. And finally, we put type-specific constraints last. This helps me a lot when having to quickly read dozens of complex schemas, and I think you would enjoy it as well. So yeah, give it a shot. Moving on, vast majority of software engineers make use of software linters for any half-serious project. Again, you probably take them for granted for code, but then for some strange reason, most people don't lint their schemas at all. But actually, linting is essential to uncover lots of the issues and bad practices early on. Just seeing what the linter complains about can also teach you a lot about what the best practices are. Take this schema as an example. Seems sensible. Defines type to be a string, and it defines an enumeration of 3 string values. See a lot of developers writing schemas like this one. However, if you look more closely, it turns out that the type keyword here is actually doing nothing, as the enumeration implicitly checks for the type of its options. If you run the linter that I ship with my JSON Schema CLI, it will complain about exactly this, pointing it out as an anti-pattern. And as a bonus, like other popular linters, my linter supports -- fix option for most rules to automatically go and fix them all for you. This is a really simple way to improve your schemas. And let's go to the next one. If you're working on any project that cares a bit about software quality and stability, you are very likely very accustomed to writing unit tests. However, you would be surprised by how many people completely forget about the idea of unit testing when it comes to schemas. I saw countless of schemas that don't work as expected, often by being more liberal than intended because nobody actually cared to test them out. Now, a JSON Schema CLI supports a test command that implements a unit test runner for schemas. And let me show you how it works based on this example schema that I have right here, which is validating strings that correspond to years. At the right, let's start writing our tests. First, we will define the target of this test suite to be the identifier of the schema at the left. This is essentially how we're saying that this test suite is testing that schema. And we will proceed to write the first test. We set a sensible description, we say that we expect it to be valid, and we set the instance of the string 2024. Now let's add another test that checks that the year 0 is not a valid year, which is actually not according to the ISO if you check. Finally, let's write one more test that checks integer years are invalid as well. Then we can run the test suite as follows. We run the JSON Schema test command, passing a few arguments. The first one that I'm highlighting here imports our schema into the resolution context of the CLI, so the CLI can find it. If you run the CLI in verbose mode, it will tell you the schema is getting imported. Then we pass our test file as a positional argument. And then you get a pretty nice summarized test output like what you would expect from any other unit test runner. And just to reiterate on this, I strongly suggest you start unit testing your schemas today, mainly the ones that are non-trivial. It is very, very easy to get schemas wrong. I'm a TSC member of JSON Schema, and I would still make a lot of silly mistakes if I was not unit testing everything. And in case you're curious, the syntax of my test runner has been directly inspired by how the official JSON Schema test suite is defined. You can check that on GitHub. So let's step back for a moment. So far, we discussed a lot of things that you can do to improve your schemas, from checking them against their meta-schemas, formatting them, linting them, and testing them. At work, you very likely also are doing all of these things on a CI/CD pipeline to make sure that every pull request coming in adheres to such high standards. In the spirit of treating schemas as code, you should be doing the same thing with your schemas too. In case it's useful to you, this is the GitHub Actions workflow I run in all of my JSON Schema projects. It's super simple. First, I install my JSON Schema CLI with a very easy GitHub Actions integration that I provide. Then I check all schemas against their meta-schemas. Then I check that all schemas are formatted by using the -- check option of my format command. Then I lint all schemas to find potential issues early on. And finally, I run all of my tests. And that's it. So thank you so much, and I hope you enjoyed the talk. If you liked it, you can find my JSON Schema CLI on GitHub under the source meta organization. Please give us a star and share any feedback that you have. We would love to hear from you and make sure that we're building the very best JSON Schema CLI around. So yeah, thank you very much. Bye-bye.